All right, let's get started. How are you today, guys? All good? Enjoying the conference? Fantastic. Thumbs up. See already some thumbs up over there. All right, so I'm very excited to be here to present a topic about I'm very passionate, which is how to write the next generation of user experiences, not on the 2D space, but in the 3D space, using Unity and augmented virtual reality, these new emerging technologies. But first of all, a quick introduction about myself. I am Davide. I'm a senior software engineer. I live in London, very passionate about client technologies. Started working with these emerging techs in 2017, firstly with Hololens, and then lately with more commercial focused devices like Oculus Rift or Oculus Quest. And in the past, I've been awarded 5 times as Microsoft MVP for my contribution to the communities. I usually like sharing on my blog, on Twitter, or on GitHub my different projects, what I learn. And I like collecting badges, you can see from this screen. And I like learning a lot. So I will take questions, if that's okay for you all, at the end of the presentation. If you can put your questions on the track 3 on Slack, that would be fantastic. So let's see the agenda, what I wanted to talk and guide you today. Firstly, I would like to introduce this concept of a mixed reality. Sometimes there is a bit of confusion between mixed reality and augmented virtual reality. We will try to clarify a bit over that. And then we will get our hands dirty directly with Unity, and we'll start writing a simple virtual reality experience by importing the SteamVR plugin, which is produced by Valve, the company that is behind the HTC VIVE or the Valve Index, which is a fantastic SDK for getting started with Unity and virtual reality applications. And then we will move more on natural form of interactions, not by using controllers, but by using hands and voice command. I think that voice is very, very important for adding natural form of interactions to our virtual reality experience. And then hand tracking, and then start looking more at other devices like HoloLens and augmented reality application with those ones. So let's start by introducing mixed reality. Mixed reality is, of course, the blending of 2 different worlds. The physical reality, where we live every day, where we can touch things, where we can feel stuff, and the virtual reality, which is usually generated by a hardware, a PC, a machine. When you put together these 2 worlds is when the magic happens, I think, because it is when you can enhance your virtual environment or with the different object called hologram. So if you are in your room, you can pin some screens in your walls, or if you are in your house, you can try new type of furniture by just using these devices, right? So you can save a lot of money, and we will see a lot of commercial applications that you can work with virtual augmented reality too. So to avoid any confusion of the different types of devices and realities, I found this concept of physical digital reality spectrum very, very, very useful, which is not a marketing slide. It is an academic paper wrote in 1994 by Paul Milgram and Fumio Kishino called A Taxonomy of Mixed Reality Visual Displays. In this taxonomy, we can classify all the different headsets and hardware that we can use for these emerging technologies. So if we put in one extreme on the right, the digital reality, we have that category of devices that are completely occluded. And usually you have to create a full 3D world for those devices. So if you can see here, I have an Oculus Quest 2. It is a completely occluded device. It has already some cameras for some sort of pass-through, but it is very, very early days for this pass-through. It is a virtual reality. You needed to generate a full digital world for those types of devices. Example of those devices, Oculus Quest 2 that I just illustrated, or HTC VIVE Cosmos, Valve Index, or the Windows Mixed Reality headsets. If we move towards the other extreme versus the physical reality stuff, we find those category of devices where you can see through. So classical example is the HoloLens or the RealWear HMT1 or Lynx R or the Vario XR3, which allow see through. So you usually have to provide a different way of generating your augmented reality experiences compared to the virtual reality, because you don't need usually to create a full 3D environment. You don't have this occluded headset, so you can enhance your environment with holograms and the 3D objects, etc., etc. Very important to understand the difference between the two. Why mix the reality? When I started working with these toys, I was thinking, why are you using this? Is something that from a business perspective makes sense? And so I did some research, and I found that VR AR is definitely the next computing platform. We see this shift from 2D displays through 3D displays, and so to the 3D interfaces in the space, no more with the 2D coordinates, right? So it will be a next computing platform for sure. It is estimated by 2025 around 8 billion revenue in dollars, clearly, for this augmented sort of revolution. This is some data that I got from the Goldman Sachs report or from other academic paper. Probably the numbers sometimes change a bit, 80, 90 billion, etc., etc. But it's clearly that from a business perspective, there is a shift of and an improve on this category of applications. Mixed reality is already revolutionizing a lot of sectors and a lot of application. Clearly, if you think about the Oculus Quest that I show you, it is a device where you need to project in two different eyes these 3D interfaces. So you will need such a good computing machine. So usually if you are a gamer, you already have that in-house. Gaming is one of the sectors where you can use a particularly indicated for virtual reality, of course. But other sector, video entertainment, is something that potentially could be very useful for virtual reality. For example, just pin some screens in your environment. And filmmaking, I was reading recently how one of the latest movies of Pixar, The Lion King, used the virtual reality for designing some scenes and also for filming some scenes. So there is a revolution in this sector due to this type of technologies. And most interestingly, I was reading about healthcare. So there were some studies from academia and some university that are using mixed reality or virtual reality for studying, for instance, the interaction between doctors and patients, or for curing phobias for some people. And so having also an impact from an healthcare perspective. Or real estate, take an example, the possibility of representing buildings in the location before they get started the constructions. So this is allowing a lot of money saving. And of course, the classical cases like engineering or education. Education is a particularly indicated scenario for virtual augmented reality. Think about the possibility of training your employees with these devices without having to, so saving some money. And of course, military with the simulation and so on. So how can we design for augmented virtual reality? When I started writing my first experiences, I immediately noticed, I said, hey, Davide, you are no more in the 2D world here. You are in the 3D world. So you need to think about a way of doing proper experience and proper immersion for the user. So you don't have anymore a mouse, you don't have anymore a keyboard. So you need to provide different types of design for your virtual reality experiences. I came across this concept of illusion for maximizing the immersion from Professor Mel Slater of University of Barcelona. And this enlightened me because Professor Mel Slater wrote different academic papers stating that if you want a great VR experience, if you want to give the user the illusion to be in a digital world, you need to provide three types of illusion. So the first one is quite simple, probably obvious, but if you are designing a virtual reality application, you need to provide a proper 3D environment, right? So in this 3D environment, you can place stuff, you can, for instance, representing a mysterious dungeon, but you need to provide the exact scaling of in sizes, otherwise it's breaking this sense of immersion for the user. The second one, plausibility, which is this strange term. Plausibility means if there are virtual characters or virtual agents in your experience, they sort of need to understand that you are in the environment. So if you have a virtual agent and you enter the virtual environment, the virtual agent should start looking at you or should start interacting with you, because otherwise you lose this sense of immersion. And the third one, embodiment. If you are in the virtual experience, you need to have a representation of your body. And there are different techniques for doing that. Initially, I was just representing a full body of myself, and that in some cases broke the illusion. But then if you take with this example from Oculus, you can see how just adding a representation of your hands in the virtual experience is sufficient for giving the embodiment illusion. However, if you wanted to have a full embodiment illusion, it's highly recommended. The academia also is finding some studies that you need to provide an embodiment and a full representation of your body. And this is an example of a plausibility illusion that I wrote during a small experiment that I did during a University of London specialization that I did on virtual reality. So here I was exploring how a virtual character in my scene is looking at me and looking directly to the camera. So this can be achieved in Unity by a look at transformation available in the objects. And you can see here how the virtual character, yes, it's looking at me, and me, when I am immersed in that scene, I have the impression to communicate with this virtual character. So this is an example of a plausibility illusion. And of course, the first one, the place illusion, is being directly into the environment. So let's see how we can develop these apps with which development tools are available, because the landscape here is changing quite frequently. There are a lot of tools that are coming out, a lot of new technologies. So I tried to make a very simple classification in three types. So the first one is game engines like Unity or Unreal Engine 4. So usually these game engines enable quick prototyping or virtual reality experiences and good performance. And clearly, they enable a set of actions on some models that you usually produce with different tooling like Blender or 3ds Max, etc. And you can import these assets, you can apply transformation, you can apply physics, you can apply all the different stuff. The second category is much lower level. So it is at the API level, like OpenGL, Microsoft DirectX, Vulkan. Clearly, if you want to write directly in these APIs, and at a lower level, you will need more development efforts, but probably you will have a much better performance. And performance, we will see later, is very important in virtual reality. And the third one, which is exploding, there is a lot of traction, of course, is using web technologies. So tool sets and frameworks like A-Frame or Babylon.js will enable, if you have JavaScript skills, to directly run your virtual reality experiences in the browser. And that will enable to reach many people for this. So an example of A-Frame is reported in this screen. You see how with A-Frame you already have a lot of different example and templates where you can start for. And from this one, just playing directly by pressing the VR button that you can see in the right bottom of the screen, and directly run your experiences on the device very easily. So we did a quick introduction about the different tool sets, let's see how to implement interaction in these applications. Clearly, as I explained before, you don't have a mouse, you don't have a keyboard, you need to provide something else. So we have a set of different interactions that are available for interacting with your object, with your 3D object. So one classic one is the gaze, with your camera pointing to some 3D object in your experience. You can select object in that way. And that's useful if you are using devices of the first generation, like the Oculus Go. They didn't have a positional tracking, so they couldn't track your hands, for instance. And then for selecting object, you had to use your, a method was to use your gaze directly from your camera. Gesture, of course, if you want to manipulate objects, you can apply gestures. Single or both-handed manipulatable gestures are now available with latest devices like HoloLens or Oculus Quest. Voice, which is particularly important, is a very natural form of interaction. It doesn't require additional hardware, so it's very important to enable your experience for natural form interaction like voice. And we'll see an example later. Motion control, spatial audio for receiving audio not only from the speaker of your PC, but from the 360 degrees in your environment. And spatial mapping, of course, hand tracking or eye tracking for devices like the latest HoloLens 2. Specifically for virtual reality experiences, we need usually to take care of two types of interaction. The VR interaction for selecting object and the locomotion stuff for moving into the environment. So usually the VR interaction is pointing, selecting an object, and grabbing this object with the controller. So here I have an example of motion controller from Oculus Quest. Use this controller for interacting with the objects in your environment. And when you are in a full virtual reality experience, you need also to apply this concept of locomotion, which is moving around in the environment. And this is quite important to get it right, because it's one of the main causes for motion sickness for the users. So there are different ways of doing locomotion. A lot of types of locomotion get also studied on a daily basis. So I would say that this is a sector and a field of study in continuous evolution. The teleportation is probably the most the safest one at this point, because you see an example here in the screen. You can just point a specific location in your environment with the controller, and then via this representation of an arc for being pointing directly to that location, then you can be being transported to the end location. And another method is continuous walk that needs to be implemented very carefully, because if you give the user too much acceleration, or you're not providing a constant speed, for instance, this is giving motion sickness. So that's why I usually prefer to start with the teleportation to be on the safe side, because if the user is getting sick, it won't use your experience. So we need to be very, very pragmatic on this way of moving in the environment. So VR interaction, VR locomotion are the main ways of interaction in a virtual reality experience. And we will see immediately how to implement VR locomotion and custom interaction in the Unity. So let me jump to Unity. I have prepared a quick scene here. I am on Unity. I have created a default project. So if you wanted to get started, you can just select a new project from the Unity template. The 3D template is very good to get started. Also, the universal render pipeline is quite good for mobile application. High definition render pipeline, it's usually used for the when you have high definition environments. So you need to be a bit careful of performance here for virtual reality. But these are the options. Usually I start up with the 3D template, And then you can, just to get started, use some assets that Unity provided, like here you can find a workbench and everything. And then the first fundamental step is enabling your project for virtual reality. You can do that by FI and the player settings. In the player settings, you find this option over there, XR plugin management. So this will enable your project for VR. So it's quite important. If you're using Unity 2020, which I'm using here, you need to use the new XR plugin management support, which is highlighted in this sample. If you're using Unity 2019, you need to use the legacy support. But the legacy support is being deprecated, so I think it's best to start working with the XR plugin management as soon as possible. And here you can select the target, clearly, of your application, in which device you wanted to run your application on. You can run on Oculus, on the OpenVR standard, which is enabling this experience to run on a multitude of devices. So this is something that I do usually when I have desktop VR. I try to get started with OpenVR because it's supported across different vendors. So if you write for OpenVR, usually you get for free Oculus, you get for free Windows Mixed Reality, and you get also all the different headsets in the different landscape of devices. And in this case, I enable the OpenVR loader. Specifically here, I use the plugin which is available on GitHub from SteamVR. And if you take a look on GitHub, I can provide also the link later. You can download this plugin and then install this plugin as a package in Unity. You have the Open XR plugin ready to go for Unity 2020. And here we go. When you have done these settings, another setting which is particularly useful is this one for the OpenVR. Select a single pass instance over there in order to get better performance. Quite useful, we found out. And then you select your target. If you're running on SteamVR, you need to run it on a desktop PC. So the first one is the good one. We will see later an example with the Mixed Reality Toolkit. Then we will also be able to target Android, for instance. But for now, let's go with the desktop VR. So I have enabled my VR in the scene. The next step is to use an SDK for having all these manipulations and interactions available in our scene. So for doing that, you can use the Windows Package Manager in Unity 2020 and select from the list the SteamVR SDK. So already selected in the project, so we will move faster in this way. If you import the SteamVR plugin directly in your project, you will find a folder over there called SteamVR, which will contain all the prefabs and all the stuff that SteamVR provides you for virtual reality applications. There is also very good scenes over there for the SteamVR plugin that you can test the different features that are available, like there is a fantastic longbow if you want to do that kind of stuff. And I highly recommend to take a look to the samples available in the SteamVR folder because they are pretty cool. And the first step, once imported the SteamVR plugin, is to add a representation of the player in your scene, which will enable cameras for both eyes and the representation also of the touch controllers. So if you look for the player in the folder over there, and you find this prefab over there called player, and you just drag this prefab in your scene. I usually create an empty object called the VR camera rig in my Unity scene, so I can adjust the position, for instance, of the player in the scene, if possible, and then I put the player inside that VR camera rig. I think I saw a lot of different SDKs that are also taking this approach. So I think it's quite useful to make the scenes more organized, let's say. And here you can find inside the player prefabs, your game objects, some body collider, representation of the left hand, of the right hand. So substantially, if you just press play now, and you have a headset like Oculus Rift or HTC VIVE or Windows Mixed Reality, this scene already worked. And you will be able to explore your scene. But it's missing usually one functionality that I really like, and which was breaking the immersion for me when I didn't implement, which is the snap turn functionality. So the snap turn functionality, you are in the 3D environment, you have a 360 degrees right around you, and you wanted to visit the different places. So it's usually very useful to provide the snap turn functionality. So if you press the joystick on the right, do some rotation of some degrees on the right, and on the left, rotation on the left. So I created a small rotate player script in Unity just to illustrate this. So let's jump directly on the mono behavior code. I just imported the Valve VR SDK from the SteamVR, which is available. And then I subscribe, let's say, to the events that are happening on both controllers. And if the input sources are both controllers, then it means that I have some action that are going on. And I can then verify if I have a variation on the x-axis, and if I have a variation which is minus a joystick tolerance that I set in my mono behavior over there as a variable just for optimizing some experience for the user. I found quite useful this one. Then you can apply a rotate on the right or rotate on the left by simply calling the transform.rotate on the y-axis for that rotation angle. So quite simple implementing snap turn functionality via a mono behavior using Unity. So let's jump on the scene, and we have our player implemented some rotate player functionality for the snap turn. Let's see how to implement locomotion now via teleportation. This is a complex implementation to be done from scratch. And so if we take as a starting point these implementations that are available in SteamVR, then we can customize those, and they are pretty useful. So if I search for the teleporting prefab in my SteamVR SDK, and as done before, just keep the prefab, drag into the scene, I can enable the scene for teleporting. So let's go to teleporting over there, and we see here we have the teleport script, which has been associated to my teleport prefabs, and a lot of customization that I can do for the teleport fade time, the color for the zones that are allowed to be teleported to, etc., etc. So all those customization. And interestingly, I have also another prefab, which is called the teleport point, which enables me to being transported to a specific location in my scene. And this can be useful if you need to interact with some object in a specific location. The one that I like a lot is the teleport area functionality. So suppose you are in this scene, right? You have this scene, you have this guy over there, and we have the ground, and you wanted to put a plane, like a 3D object over there, a plane, which is representing the area where you want to get teleported. So I put it here, plane, and to this plane, I added a component, which is called the teleport area. Let's see if we can see that. The teleport area is enabling teleportation directly with the default controller to that specific area. And believe me, you can easily start writing full games when you know this stuff, because when you have a teleportation, you already have the capability of writing a basic VR experience. And of course, you have teleportation, you can move in the environment, but you also need to be able to interact with elements, because otherwise you're breaking this sense of illusion that we spoke before in our types of illusion. And I would say that SteamVR is providing a very rich framework for these interactions. And usually You just need to select a 3D object, like here I have some assets in the table. I can decide that one of these assets needs to be interactable. And with this one, I can just apply some interactable scripts or throwable scripts that are available in the SteamVR plugin. So usually you just could here, you add a component and you add these interactable scripts that are coming from SteamVR, and then you are already in place in a good status for having interaction and locomotion in your scene. So we started this scene, to summarize, we configured the player with the OpenXR plugin. We added the SteamVR SDK from the package manager, and then we added locomotion and interaction. Now, if I press play on my Unity scene, and let me jump back to the slide, I will show you a demo of this running in a Windows Mixed Reality headset. I'm playing a video here to avoid motion sickness for everyone. I think this is safe when doing presentations. And you can see how the experience is allowing me to rotate, so this snap turn functionality. And it allows me to teleport into the environment in the teleport area, which I defined. And after teleporting in the environment, if I go near my teleport point that I defined before using the teleport point asset of SteamVR, I can go near my workbench and then I can grab objects. You can see how everything is taken care here. You have the physics, you have the colliders, and you have pretty much everything. And yeah, my first experiment when I started working with this plugin was clearly I was in a position how I could write also games, right? Because when you have this fundamental in place, you're ready to go to the next level. So let's see how to go to the next level, because I am a big fan of natural form of interactions. So here we are using a lot of controllers, lot of stuff, but what about taking advantage of voice, for instance? So my first research related to voice commands in virtual reality applications found that keyword recognizer is a good API in Unity if you want to just get started and having very basic form of interaction using voice. But what I found is that keyword recognizer can just recognize simple phrases, but it is extremely effective in doing that. So it is very good for getting started with the basic interactions and basic requests via voice. Clearly, if you want to add a more natural language understanding to your app, that's all another problem, because for adding that, you need to take advantage of services like cognitive services, and we will see it in a later example. So here is an example of using the keyword recognizer in Unity. You get your Unity mono behavior, you just instantiate in the start or awake method of your mono behavior a keyword recognizer, and you pass a list of strings that you want to be recognized. When one of those strings is getting recognized in the microphone, then the recognizer on phrase recognized event is fired, and you have a simple argument as a string of this event that you can use to verify which command has been requested by the user. For instance, here I was doing a small game with Unity, and I wanted to check the frame per second rate of my game while I was in play mode. So I added this show FPS command using the keyboard recognizer that enabled me, when it was recognized, to show a simple UI overlay on the screen showing the frame per second, and what particularly is useful for development. But you can do a lot of other stuff, like you can provide help to the user, for instance. I spoke briefly about what about language understanding. Language understanding is very complex, is very, very complex. So usually if you wanted to provide a full language understanding experience, you need to use advanced concepts like machine learning or artificial intelligence, etc., etc. So if you use this link between the intelligent edge, your device, and the intelligent cloud services like cognitive services by Microsoft, you can, for instance, start with the language understanding services and then provide a language understanding experience to your virtual reality application. So for doing that, I just created a new language understanding application in the Azure portal. And then after you have this language understanding app, you clearly need an API key that will enable the REST call to this API. Before starting using your app that you can define always in the Azure portal, you need to provide a set of intents that you want to be recognized by the cognitive services. And you also need to train your model by providing a set of phrases that you want to be recognized. So for example, here I wanted to provide some help for the user. And help can be requested in several ways. And not all the ways contains the word help. So you could say who can help me, but what should I do is another plausible request for help. So if you train your model in the cognitive service portal for intents of providing help, and then you deploy your model to the cognitive services endpoint, then you are ready to use this model in your Unity apps. So how did I use this cognitive service instance in my Unity application? So this time I couldn't use the keyword recognizer because I needed to capture all the words from my microphone. So I had to use the dictation recognizer, which is very similar to the keyword recognizer, but it's just recognizing every word from the microphone. So that's pretty simple to use. You instantiate one instance of the dictation recognizer, you set up various parameters for the timeouts, etc., etc. And when you have a dictation result event, which is fired, then you can start to grab the text from the microphone that has been submitted to the microphone and send this text as a string via an API REST call to the cognitive services. And the Unity, I did some prototypes in the past, creating when I was with the HoloLens, using HoloLens with some DLL that were created with the Universal Windows Platform that were working okay, but I think using the Unity Web Request object available already in Unity is probably the most powerful tool, because then you can write this experience and then deploy to multiple devices. And also it's very simple. So you can just create a Unity Web Request to the LUIS endpoint that is provided in your Azure portal, and then passing the query string, that is the string that you get from your microphone, and the cognitive services will return a JSON. And from this JSON, there will be the entities that have been recognized. So you can decide, for instance, that if an entity has a score of more than 65%, then it's a good candidate for a good recognition of an intent. And then you can, for instance, handle ensuring help to the user. So that's pretty much very simple then to set up speech recognition with the language understanding in your Unity VR application. And then I took together the interactions and locomotion that we saw before with SteamVR. I got a very good environment from the Unity Asset Store from a mysterious dungeon and decided to write a small game, right? I wrote this game as a part of Udacity Nano degree that was doing on with virtual reality. You can see here I requested help via the phrases, "Can you help me?" It showed me overlay with the instruction for the user. Using VR locomotion and teleportation, I can move into the environment and I can provide this way of moving and exploring all the stuff. I can interact, collect objects. I can apply some game mechanics for collecting some collectibles and giving a score to the user in order to make the user sort of very much happy with this experience and wanted to get more, right? And here you can see a skeleton. You can then, using the trovable script, collect some object in your environment and then apply all the transformation. So I think here the lesson that I learned is that with just interaction, locomotion, and some basic voice command, you can write a full game, which is pretty much amazing. And I can assure you that when I got my first game on my Oculus Rift headset working in virtual reality, I was pretty excited to get it. All right, so let's see what I learned during this experience. So one example of OpenVR is that you can target multiple headsets. So technically, if you have OpenVR enable your app, you can run your app on Oculus Rift, on Index Valve, or Windows Mixed Reality. So single code base target multiple headsets, pretty powerful. But what I found is that there are always some micro variations that you need to apply on the camera, because the SDK of Oculus is doing something different. The SteamVR with the Windows Mixed Reality is using a different hardware, so the camera can need some adjustments, etc., etc. So one example of this is creating an headset manager script. In this headset manager script, we can use the XR device API in Unity to identify which headset you are running your experience on, and depending on the headset, you can do some micro variations. And clearly, it's not a pattern that I would encourage to overuse, because it would lead to some messy code in some instances. But for some fine, very small adjustment, I think it's perfectly fine. So you call your XR device .model, you get the type, which is Oculus, Vive, or Windows Mixed Reality, and you can apply those transformations if needed. And then when I was developing this game, I noticed immediately this problem of performance. The performance is a very, very, very big issue in virtual reality. So let's take an example. If you run your experience on an Oculus Rift headset, you need to run it at 90 frames per second. If you are starting to run your experience on half that frame rate, it means that the user is probably getting sick. So when you are developing for these types of applications, you need to be very careful about performance. I suggest for performance to look at the different vendors. They have all some fantastic papers, Oculus, Windows Mixed Reality, etc., etc. Every platform has its own characteristics. However, there are some stuff that I found that are quite general. The first one is for helping the batching, helping the performance, mark that not moving object as static. So if you have an object that is not moving, just mark it as static. And I found this script for myself quite useful during development, because sometimes you have a lot of objects in your hierarchy, and so you can put a script like this in your scene, and with this script identify which objects are static or not, and then do what you deem necessary in that case. The second very important stuff that I found is baked lights. So if Unity by default uses real-time lighting, and this is very, very expensive for performance of virtual reality. If you apply the baked lights and you disable the real-time lighting in Unity, this is very, very useful for performance. And avoid not performing code at runtime. This is fundamental. So methods like get component are very expensive. So if you have an update method on Unity, which is running at 90 frames per second, you really don't want to call get component in the update method. For instance, debug.log is very expensive. So if you call it in your update method, it's very bad too. And some other tips like strings are immutable, so you can just define strings as a constant in your mono behavior and then reuse that constant, avoiding this creation of new instances of strings at runtime. And so these are some tips that I found during development, very useful for me because they enabled my experience immediately to achieve better frame rates. So we started this journey into the emerging technology with the virtual augmented reality. We talked a lot about virtual reality, but we started adding more natural form of interaction using voice. Let's see now how we can implement also hand tracking, which is an additional natural form of interaction in our experiences. So usually, if you want hand tracking, you need to go to expensive devices like HoloLens or Magic Leap 1. But fortunately, in the latest months, Oculus released some updates to Quest, so you can use hand tracking with Oculus Quest. And this is also very useful because you can start prototyping on Quest and then move your experience on HoloLens or other devices in a second moment. What I found very powerful in terms of manipulation is the mixed reality toolkit for Unity, which is a project on GitHub developed by Microsoft, the community, initially for HoloLens, and now is enabling the target of a wide variety of devices. So you can, for instance, apply hand tracking and hand transformation using mixed reality toolkit now on Oculus Quest. And so you have a lot of different types of manipulation, like single or two-handed manipulations, and a lot of common objects like slider or scrolling of different information on boards, etc., etc. So let me jump on another demo now, doing hand tracking with Oculus Quest using the mixed reality toolkit. The mixed reality toolkit can be imported in your project, as we saw before with the package manager. We did it for SteamVR. You can do for the mixed reality toolkit. You can import it, and then you will have available some menu option for Oculus and mixed reality toolkit too. From this option, you can then enable your scene for the mixed reality toolkit object. So usually you can just simply add a mixed reality toolkit and a play space over there, and your experience is ready to go. And a trick that I found is you can also import the Oculus SDK. Via the Oculus SDK, you can easily enable the hand tracking in your scene, and using project from community member that I will put on my blog lately after the end of this session, you can easily get, for instance, two-handed manipulation applied to your object. So suppose you have the cap here or your scene, you select your cap over there, and from your cap, you can just add a script and a component. And if you select a component with is called Object Manipulator in Mixed Reality Toolkit, you enable a pretty cool functionality, which is the pinch and zoom functionality, but in the 3D space, which can be particularly effective for exploring models, or suppose you have a big motors, right? And you want to explore all the details from a near position, you can do that with this Object Manipulator script. So if you run your scene now, let me go back to the presentation quickly, and let's see this scene executing on an Oculus Quest. You can see here, I can also play a piano. I'm not sure that play piano is one of the best applications for hand tracking, but it's very fun, this sample that Microsoft provided in the mixed reality toolkit. I have a full hand tracking just via the Oculus Quest, and the same application could be potentially just executed on the HoloLens. I can perform scrolling on information. I can do resize of objects in the space, etc., etc., and explore the different types in the environment. So pretty cool and pretty powerful to use. And I think the lesson here is that there are several SDKs available, SteamVR, Mixed Reality Toolkit, Oculus, depending on the type of application that you want to write, probably that will drive the choice of the toolkit. So, and we are moving towards now the other extreme of the physical digital reality spectrum, and we're going versus AR. So one of the first applications, just for illustration purposes, that I wrote was with HoloLens. Clearly on HoloLens, you have a lot of sensors. You have depth cameras, normal cameras. You have gyroscopes. You have eye tracking. You have hand tracking. So the types of applications that you can write are quite different from a virtual reality experience. So the hello world for augmented reality using HoloLens for me was just write a simple object recognizer using cognitive services and HoloLens. So just grabbing a photo from the camera, sending the photo to the REST services of cognitive services, getting this object recognized. So I started by creating a simple app on a universal Windows platform target, just for having a simple DLL, which is using a NuGet package for calling the cognitive services vision. Pretty much simple. You call with your API key and everything, and if you pass an image, a bitmap image, in the endpoint, then you get from the cognitive services a description of your services. Here I got a photo from the Microsoft headquarters in Reading, and you can see that you can recognize the building, you can recognize the different objects in the photo with a pretty good confidence, I would say. And then you can create a universal Windows platform app in Unity, import your DLL created previously in universal Windows platform, and then reuse this DLL for your application and your experience on Unity. And here I put together an example when via voice I was saying the word analyze, and then HoloLens was recognizing that command and was sending a cognitive services call to the Vision API. So pretty much cool. Can think in the future when we will have headsets that will be miniaturized in glasses like this one that I have, and you could provide a lot of benefits for visually impaired people, for instance. That's pretty much amazing. There are available a lot of other services in the landscape of mixed reality now. Suppose, for instance, remote rendering. If you have a polygon or 150 million polygon model that you need to render on the device, that's quite a big problem, because a mobile device like HoloLens or Oculus Quest can render maximum 400,000, 500,000 polygons. So one technique for rendering a lot of polygons in the mobile device is using remote rendering. Render in the cloud and just send the result to the headset. So you can, or take an application like photogrammetry, for instance. That's a sector where remote rendering could really have a lot of application. Spatial anchors for anchoring objects in the environment, but not only in your room, in your environment outside the real world. So you wanted to place an object in London, go back to Italy, come back to London, and find the object in the location in London specifically where you position that. So spatial anchors is a fantastic service from the Azure Mixed Reality Services, which has been recently also extended with the concept of object anchors for pinning 3D models or holograms directly to yourself as a player. So to summarize what we looked together, we started by introducing the concept of mixed reality, and then how to develop for AR and VR via the three types of illusion, which are very, very important for me. And we wrote some VR interaction and locomotions using the SteamVR plugin, very simple to use, get started in literally minutes for doing prototyping. And we extended that up with the vocal commands and performance, very, very important, hand tracking using the mixed reality toolkit and the latest mixed reality services. So To conclude, what are my key takeaways that I got while developing these apps? So the performance is very important. You need to check early and often to avoid motion sickness. So you need to embed this in your development workflow. Otherwise, you will have big problems. You need to test them frequently on the target device and check the frame per second to have optimal experiences. Design properly the experience for the three types of illusion: place illusion, plausibility illusion, and embodiment illusion. They are fundamental. We are no more in the 2D world, we are in the 3D space. So we need to think in a different way. And the cloud services are becoming essentials for enhancing the user experience. Cognitive services or mixed reality services like object anchors are fundamental and will become more and more fundamental in the future. And I would like to conclude with a phrase from Arthur C. Clarke, Profiles of the Future, 1961, that any sufficiently advanced technology is, of course, indistinguishable from magic, because I feel that when you work with this stuff, it's real magic. So thank you very much. I will put my slides in my blog and on GitHub, there will be all my example. If you need to contact me, I am here for questions. I think we have 4 minutes. I will pick up some questions here. Otherwise, you can write me on Twitter or by email. I will leave all my details here. Thank you very much.